Hello class and welcome to today's electrical installation and maintenance video lesson. My name is Roger Manilhig and I am an electrical installation and maintenance instructor. Now before we begin today, let me tell you a story. Be sure to listen to the story because after the story we will have our first activity. Now just a disclaimer, the video is not mine. All credits are given to the owner and special thanks to the owner. Are you ready? Now let's listen to the story.
Electricity was a discovery, by the work of many great minds, throughout history. Electricity is a natural phenomenon, that occurs throughout nature, and takes many different forms. It has been existing, right from the beginning of the earth, in the form of lightning. Long before any knowledge of electricity existed, people were aware of shock, from electric fish. Ancient Egyptian texts referred to these fish as the thunder of the Nile. Amber is a fossilized tree resin, and ancient people knew that amber rod could be rubbed with cat's fur to attract light objects like feathers. This was later known to be static electricity. Around 600 BCE, Greek philosopher Thales of Miletus made a series of observations on static electricity. But it wouldn't be until the 1600s that it was studied scientifically. The term electricity was coined in the early 1600 AD by a British scientist William Gilbert, who was studying the effects of electricity and magnetism on amber. In the 18th century, Benjamin Franklin conducted extensive research on electricity. He was able to prove that lightning was a form of electricity by his famous kite experiment. It was performed in Philadelphia in June 1752. Also, this experiment led him to invent the lightning rod. He flew a kite into an approaching thunderstorm. With the help of his son William, he made a simple kite with a silk handkerchief instead of paper, as it would not dare with wind and rain. He attached a pointed wire to the top of the kite as a conductor. At the bottom end of the string, he attached a silk ribbon. The ribbon was kept dry, as it was held by Franklin in the doorway of a shed to protect himself from being electroshocked. A metal key was fastened where the string and the ribbon join, and was connected to a Leyden jar by metal rod, so that it could accumulate electricity. Leyden jar is a device that could store an electrical charge for later use. When thunderclouds passed over the kite, Franklin noticed loose threads on the kite string starting to stand on end. He then touched his knuckle to the key and received an electric shock, proving that the kite was conducting electricity. The kite was not struck by lightning directly. Instead, the conductor drew the electrical charge from the storm clouds to the kite, and it flowed down the wet string through the metal key into the Leyden jar. He was even able to collect some of the electric charge in the Leyden jar. Through such people as Alessandro Volta, Michael Faraday, Nikola Tesla, and many more great scientists, electricity turned from a scientific curiosity into an essential tool for modern life. We use electricity for almost everything we do, every single day of our lives. We use it for devices that we are increasingly dependent on. We use it for home appliances, to keep ourselves and our homes comfortable. And also wireless transmitters, data centers and factories are built with huge power demands. The discovery and harnessing of electricity help to keep our lives functioning.
So, did you like the story? If you did, you will love our next activity. Let's call it Who Am I? It's quite simple. You just have to answer the questions being asked. Are you ready for the game? Then let's begin. And now for our first question. I am a Greek philosopher who made series of observation on static electricity. Who am I? You have 15 seconds to answer. Timer starts now. Time's up. Now, what's your answer? If you answered Thales of Miletus, you are correct. Good one. And now for our second question. I coined the term electricity in the early 1600s. Who am I? Timer starts now. And time's up. What is your answer? Now, if you answered William Gilbert, you're definitely correct. Another point for you. Okay, now let's go to the third question. I did the famous kite experiment to prove that lightning is a form of electricity. Who am I? Timer starts now. Time's up. Now, if you answered Benjamin Franklin, you are correct. Congratulations if you have 3 points. If not, that's all right. There's always a next time for this. And let's move on to our next activity. And now for our next activity, it's called Few Picks, One Word. It's simple. I'm going to show you pictures. Then out of these pictures, you get to think of what do these pictures have in common. After that, the number of letters should correspond with the number of empty boxes you see on the screen. Simple, right? Let's begin. Now for our first word. Are you ready? Alright, let me show you the pictures. Timer starts now. Okay, so what is your answer? If you answered electric, you are correct. Good job. Now for our second word, let me show you the pictures. Timer starts now. Okay, so do you have an answer now? If your answer is circuit, then you are correct. Alright, so the first word is electric. The second one is circuit. It's pretty obvious that we are going to talk about electrical circuit for today. We also have some basic wiring, but before that, let's get to the objective first. Okay, now let's go to the day's objectives. First, define what is electrical circuit. Next, discover the parts and types of a circuit, series and parallel. Third, enumerate the 3 important steps in wiring. Next, demonstrate how to wire series and parallel circuit. And the last one, appreciate the importance of correct drawing and interpretation of electrical circuit. Now let's define what is an electrical circuit. Electric circuit is a path for transmitting electric current. An electric circuit includes a device that gives the energy to the charged particles constituting the current, such as battery or a generator, devices that use current such as lamps, electric motors or computers, and the connecting wires or transmission line. Now, if you will look at the small image or the moving image on my left, you will see that the device that has a charge is the battery. Now, the red tiny spark there, it represents the current. Now, as you can see, the current comes from the battery. That's the source. Now, it passes through the wire so that it can get to the switch. Now, it passes through the switch. When the switch is on, it can continue its path. Now, once it has passed the switch, it will go to our bulbs. Now, the bulbs, once the spark gets to the bulb, the bulb lit up. It lights up rather. Now, as you can see, the spark after the bulb, or the spark that comes from the bulb, goes back to the battery. That's how the electric circuit works. We are going to talk about this more and more as we go through the activities for today. Okay, now let's talk about the four parts of an electrical circuit. The electrical circuit has four parts. First one is the source, followed by the path. Then you have your load. Then the last one is your control switch or control device. Okay, let's first talk about the source. Okay, source is where the electric current starts to flow. The power of the source can be a generator, storage cell, or more cells. Now if you look at the pictures above me, those are the examples of the sources of electricity. We have there the battery, then the generator, and as you can see, we also have the most common thing we see inside our houses, the convenience outlet. Okay, now those are the source of electricity. Okay, now let's talk about the second part of the circuit, which is the path. The path is defined as, these are electrical wires. Okay, these are the wires needed in order for that electricity from the source can be transmitted. Now, the simple explanation of this is that the path or the wires simply allows the electric current to pass through the other parts of the circuit. Now, a while ago in our animation, we saw that the current comes from the battery. It passes through the wire to get to the switch. Now, after the switch, it uses the wire again to get to the bulb. Now, after the bulb, it uses the wire once more to get back to the source. Now, let's talk about the third part of our circuit, which is the load. Okay, let's define. Load is a current-consuming device or appliance that will consume or use electricity. Okay, now these are the devices that uses electricity to function. Examples are the bulb, the electric fan, the refrigerator, and your television. Now, the load is, like I said, it's anything that uses electricity to function. Okay, I'm sure you can think of other examples of load that consumes electricity. Now, the fourth and final part of our circuit is the control switch. Okay, let me just read this out for you. The control or switch cuts off the flow of current when the appliance will not be in use. Now, this is very important because the switch is your control device. It allows you to cut. Okay, when we say cut, it cuts the supply of electricity. Therefore, your appliance will not function. Okay. Now, in case that you want your appliance to work again, or if you want to switch it on, if you want to use it, you simply switch it back on. Okay, that's how the switch works. It cuts and connects your circuit. Okay, now when the switch is on, your appliance will work. Okay, when the switch is off, your appliance will simply will not consume electricity. That's the use of the switch. Okay, the examples you'll be seeing on my right is the first is the toggle switch, and the small switches. Those small switches, we use them on mostly on electronics or vehicles. And the last one is the common switch that we see in our houses as well. Okay, just an additional info. It is called the three-gang switch. As these are the parts of the circuit, you have your source, and this is our AC source. Okay, you have your pad. So these are your pad, the wires. Okay, then you have your load, and this is your switch. Okay, now again, the source, this is where the electricity or the current comes from. Okay, now this is the path. This is where your current flows or travels to get to the load to light it up, and it goes through the wire again, goes to the switch, passes the switch, and gets right back to the source. So your switch simply cuts the power and restores the power, just like that. Okay, that's how you do it. And these are the four parts of the circuit. Now in a series circuit, it works this way. Many bulbs, so you have three bulbs, A, B, and C, are connected one after the other. So it means that your current will come from here, it goes to bulb A first, then it passes through bulb A, then goes to B, passes through B, then goes to C. Again, it passes through C, then goes right back home to the source, passing through the switch first. So imagine if this bulb is busted, your current will not complete the circuit. So current will come from here, goes through there, and at this point it cannot go, it cannot and at this point it cannot complete its circuit because there's a gap on the circuit. What's gonna happen if you do this on actual wiring is bulb A and bulb C will not light up. But if you put the bulb back on, say if you replace the bulb, that completes the circuit again. Then all of these three bulbs will light up once more. So in a series circuit, if one bulb gets busted, there's going to be a gap on the circuit. So this circuit will not work anymore. Okay, now this time we will draw the schematic diagram for parallel circuit. So let me just erase this. Now if you'll trace the movement of electron is your current will pass through here, goes through there, goes through here, passes the bulb, goes to the wire again, jumps over here because that line is not connected, passes through here, jumps again, goes through here, then it can go right back to its source. Now for bulb B, so current goes through here, passes through there, goes to B, exits B, goes through here, jumps over like that, and goes through here, and goes back home to your source. Now for C, it's the same thing. So let's just trace the lines. So your current comes from here, it reaches terminal 1 of bulb B, just like that. It passes through C, rather, that's the bulb C, passes through C, and comes right out over here, and there you go. It can go right back home to its source. That's how the wiring for parallel circuit is. So each bulb has its own circuit. It's not dependent on one another, because if say this bulb here gets busted, the current can still go home back to the source. Let me show it to you. Okay. So again, let's just do some simple line tracing. So current goes through here, goes through there to get to A rather. Current passes comes out from here, then travels through this line. It can still pass through here, then it can go right back to the source. So meaning, even with the absence of bulb B, bulb A will still light up. Now let's check out if that's the same for bulb C. So let's just trace the current. Again, current comes from line 1, or it can come from line 2. Line 1, current goes through here, makes a turn in here, goes through C, passes through C, then back to the wire, and there you go. So that's how the parallel circuit works. Okay, so let me just put B back again. Because we're gonna use this for our wiring exercise. Now let's talk about the 3 important steps in wiring. Now, these steps are essential if you would like to be a successful electrician someday. Now let me walk you through the steps one by one. Okay, first thing that you would like to do is you must draw out your electrical symbols. Oh, by the way, I'm gonna demonstrate the 3 steps I'll be using the schematic diagram to demonstrate the 3 steps. Okay. First is you wanna draw your load. Okay, so let's say our load is a light bulb. Okay, so the symbol for bulb is this one. Okay, that's your bulb. Okay, now this time let's draw the switch. So symbol for switch is this, looks like this. You box it. Okay. Now you have your switch. Now this time let's draw the source. Line 1 and line 2. So meaning our circuit has an AC source. Okay. Now this time is we will utilize the 3 important steps in wiring. The first one is terminal 1 of your load, so this is your load, is connected to line 1. So for the sake of beginners, let me just tag our terminals. Okay, so this is terminal 1, this is terminal 2. Let's do the same thing for our switch. So terminal 1 and terminal 2. Okay, now let's proceed with the steps. Okay, step 1 says line 1 is connected to terminal 1 of your load. So this is your load. Okay. That's the load. So let's simply draw a line and let's connect line 1 to terminal 1 like so. So you have your step 1. So this is step 1. That's it. In electricity, we call this line the hot wire bulb. Okay, hot wire bulb. Okay, so that's it. Again, step 1 is line 1 is connected to terminal 1 of your load. Okay, now let's proceed with step 2. Step 2 says line 2 is connected to terminal 1 of your switch. So this is terminal 1 and this is line 2. So let's simply draw a line to connect line 1 to terminal 1, or to connect line 2 rather to terminal 1 of your switch, like so. So now you have step 1 and step 2. Okay. Now this time let's call step 2 as the hot wire switch. So that's your hot wire switch. So what do I mean by hot wire? Hot wire simply means that this line has current passing through it. Okay? Same goes for this one. And that's how alternating current works. Line 1 is energized, line 2 is energized. So you should never put those lines together without a load, because you will have a short circuit. But that's another lesson. Okay, so let's proceed with step number 3. Okay, so step number 3 is simply your return line. So how do we go about step number 3? Step number 3 says terminal 2 of your load, so this is your load, is connected to terminal 2 of your switch. So let's simply draw lines again. Okay, connecting terminal 2 of your load to terminal 2 of your switch. So that's step number 3. Let's call step number 3 as the return line. Okay, now on our previous definition, electric circuit is the transmitting of current from the source through the switch and through your load, then back to the source. So that's why this one is called return line. So your current comes from here, it passes through the bulb, goes here, goes to the switch, goes back, goes through the switch, then back to the source. That's why this one is called return line, because your current in alternating current comes from here, goes to there, to the load, to the line, to the switch, then back to the source. Or since this is alternating current can also come from here, goes through the switch, passes the switch, goes through the load lights up if the switch is closed, then goes back to the source. That's why this one is called the return line. So again, so this is your step 1. Line 1 is connected to terminal 1. Now step 2, line 2 is connected to terminal 1 of your switch. Okay, now this is step 3. Line 2 of the load is connected to terminal 2 of your switch. Now doing this, you can never go wrong on your electrical wirings. So that's why I coined it, or that's why I called it as the 3 important steps in wiring connection, because you can never go wrong once you have these steps memorized. Okay, like you have to know this like the back of your hand. Okay, so once more, line 1 is connected to terminal 1 of your load, line 2 is connected to terminal 1 of your switch. Then for the last step, your return line, terminal 2 is connected to terminal 2 of your bulb is connected to terminal 2 of your switch. Okay, that's how it's done. Now this time we'll do the steps using actual materials. First, when you're doing your work, you always have to wear PPE. PPEs are gloves, face shields, earplugs and stuff. PPEs are things that you wear to protect yourself from hazard or harm that might happen while you're working. So I have my gloves on, let's see. When doing actual wiring, you have to draw your diagrams first. So that's what we did. Put that right there. Now let's do first step. First step is put that aside. Line 1. So this is your line 1. Line 1 is connected to terminal 1. So this is your line 1 and this is terminal 1. So we'll just screw it on one of the terminals. Simply slip your wire like so. Slip it in. And just twist the wire so that I can easily insert this. Wires there. Tighten the screw like that. You have your step 1. That's it. Now step 2 is line 2 connected to terminal 1 of your switch. So if this is line 1, this will be our line 2. So let's grab the switch. Same thing. Turn the screw. Loosen the screw like so. So now we have step 2. Terminal 2, line 2 is connected to terminal 1 of your switch. Okay, now, so that's line 2 connected to terminal 1 of your switch. Now let's proceed with step number 3, which is terminal 2 connected to terminal 2 of your switch. Let's do that. So first work on terminal 2 of our load. Just to make things clear, this is not the load yet. This is what we call a receptacle. Now when you put the bulb here, now this is your load. It's just that using the receptacle, it makes your wiring a lot easier instead of using some electrical tape to connect your wires here. So this is actually the lamp holder for the bulb. This is the lamp. So let's do that then. Slip it in there. Nope, won't fit. Let's twist the wire. So that's your terminal 2 of your load. Let's connect terminal 2 of the load to terminal 2 of our switch. again, let's review. So terminal line 1 is connected to terminal 1 of your load. Step 2, line 2 is connected to terminal 1 of your switch. Step 3 is terminal 2 is connected to terminal 2. Terminal 2 of your load is connected to terminal 2 of your switch. Okay. Set it down real easy. Put the bulb here. Let's go over this. Let's just leave it on like that. Let's try it on. And that's how you do it. Now before we start wiring, let's get to know the tools and materials. Now these are the tools and materials for our wiring demonstration. First is we have our PPE, the gloves. And for our tools, we have the Phillips screwdriver, combination pliers, cutter. Next is whiteboard markers, whiteboard eraser, and of course, whiteboard. We'll be using this three for our diagram. Now for our materials. Switch, 3 pieces receptacles or lamp holders, 3 pieces light bulb or some wires, and a male plug, and of course our AC source. Okay class, now we shall proceed with our wiring demonstrations. First thing that we're gonna do is we're gonna demonstrate how to wire a series circuit. Okay, now like any other wiring exercise or wiring project, you always have to draw your diagram first. Okay? So this time we will draw a diagram that has 3 bulbs in a series connection. So, first things first, you must draw your loads. Like that. So this is your line 1, then line 2, and let's put our switch right over here. Now simply connect the bulbs and the switch all together. Now for series circuit is line 1 is connected to terminal 1 of bulb A. Let me just mark that. That's A, B, and C. Okay. Line 2 is connected to terminal 2 of your switch. Just like that. Okay. Next is you connect terminal 2 of bulb A to terminal 1 of bulb B. Then terminal 2 rather of B, you have to connect it to terminal 1 of C. After that, you simply need to draw your return line. So that's going to be terminal 2 of C connected to terminal 2 of your switch. Okay. Okay, now that we're done with our diagram, we can now do the actual wiring. Okay, let's put this aside. Put it over there. So wear your gloves. Okay, so what we want to do is we want to do this first for bulb A. Okay, let's do that. Let's get our wire, our receptacle. So this will be your first terminal. Okay, so that is that's A. Okay. Next is B. What are we doing B? So this, so from A we have to connect a wire going to bulb B. So let's get another wire. So now we have B. Just put this aside. So you have your A. This is your B. Okay. Next is bulb C. So now we have bulbs A, B, and C connected in a single loop. Okay. Now let's do this. Bulb C going to our switch. That's done. So this is your C going to your switch. Now let's do this. Line 2 is connected to our switch. We just have to grab another line from the male plug. So this is your connection.
Oh.
Now what we did this time is we had to replace this bulb with this bulb because it will not show us the result that we need for this demonstration. So let me go ahead and place these bulbs now on our receptacles. Okay, now let's cover switch. Okay, let's try it on. Okay, just give me a minute, just a second. Switch. Let me just turn off the lights. Okay, as you can see, our bulbs does not shine that bright enough because they are sharing the voltage. Now this is what happens on a series circuit. Okay, now let me show you one more thing. Now if this bulb gets busted, the other two bulbs will switch off as well. I replaced the bulb. So that's what happens when you remove a bulb from the series, on a series circuit rather. All of the lights will turn off. Alright, and that's how you do, or that's how you wire a series circuit. Now this time we will have a demonstration of wiring a parallel circuit. Okay, now this time we will draw the schematic diagram for parallel circuit. So let me just erase this. B and C. So for drawing your diagram for parallel circuit is you have to supply all terminal ones with line 1, because that's the first step. So I'm just gonna drag a line up until here. Then I'm gonna connect terminal 1 of bulb A to line 1. Same goes for B, then for C. Now I have all terminal 1s connected to line 1. So bulb A gets its line 1 this way. Bulb B gets its line 1 because I have extended the line, so just like that. Then bulb C gets its own line 1 as well. Okay, so that's step 1. Now let's go to step 2. So line 2 is connected to terminal 1 of your switch. And there you go. Now what we're going to do is we have to supply all terminal 2 of your bulbs to terminal 2 of your switch. So to do that, we have to draw a line this way. Now this line means that it's wires intersecting but not connected. Okay. And let me connect that to terminal 2 of your switch. Now since I have a line that goes here through here, I can simply connect terminal 2 of each bulb to terminal 2 of the switch. Okay, so that's how it's done. Okay, this time let's use the diagram to do the actual wiring. Okay, now for wiring parallel circuit is we have to supply all of the bulbs with line 1. So to do that, we have to use an extension wire. Okay, so for step 1, connect line 1 to terminal 1 of bulb A. Okay, we have to insert an extension line in here to supply line 1, or to supply bulb B with line 1. So, this is now your extension of line 1. So we're going to connect this wire to bulb B. Okay, So this is the receptacle that we will use for bulb B. Now I'm going to use another extension wire because I have to extend line 1 to bulb C. Okay, are you following me so far? So this is your line 1 for bulbs B's terminal 1. Just insert it like that. Pause move it. So this is our extension wire of line 1 from bulb A rather. So I'm gonna insert another extension wire to bulbs B's terminal 1 so that I can supply line 1 to bulb C. Okay. Pause muna dyan. This is your extension wire. This is your extension of line 1 going to bulb C. Let me just remove this. So since we only be wiring, we only have 3 bulbs for this demonstration. We won't be using, we will only be inserting 1 wire in here because we don't have the 4th bulb that we need to supply line 1 with. So let me show you this. I want to show this to you. So this line, this is A, okay. This is A, this is line 1, this is terminal 1 of A, so this is line 1. Now this is your extension wire going to bulb B. So this line it's still line 1. Okay, so to extend line 1 to bulb C, I've inserted another extension wire. So this is the wire right here. So this line represents our connection. So if you look at it closely, all of your bulbs are supplied with line 1. Okay, so that's terminal 1, terminal 1, terminal 1, all connected to line 1 of your source. Now let's do terminal 2. Okay. Okay, now let's do the second step, or let's do the let's wire terminal 2 of our loads. So that's terminal 1, terminal 1, and terminal 1. Let's do this time, let's do terminal 2 of our loads. Okay, so I have 3 loads. I'm gonna need 3 wires. Okay, put that there. 3 wires. 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 3 wires So this is terminal 2 of bulb A. Terminal 2 of bulb B. Terminal 2 of bulb C. So there you have it. We have wired all of line 2, all of the line 2 of our loads. So just fix this. Show this to you clearly. Okay. So this line over here, if you remember, that's our line 1. Okay, terminal 1 connects to line 1. Now this wires over here, this is line 2, and line 2. So okay, before we connect all of our terminal 2 to terminal 2 of your switch, I have already connected line 2 to terminal 1 of the switch. So this is terminal 1. Now this is terminal 2. We will simply connect all of the lines. So this is terminal 2 of our switches, meaning this wire right here is terminal 2 of our switch. So you simply have to put all the lines together. This is terminal 2 for bulb A. Terminal 2 for bulb B. And terminal 2 for bulb C. Now we just have to twist them all together. Now it doesn't have to be this short. I mean, okay, now all of the wires for our terminal 2 is connected. There you go. Now all of our terminal 2 now all of okay. Now all of the terminal 2 of our loads is connected in this wire right here. Now this line is from our terminal 2 of the switch. Now as you can see, we have 3 wires in here. So this is for A, this is for B, and this is for C. Okay, now let's use our tester to check if there are any shortage in our circuit. So I'll set the tester to buzzer. Okay, when you hear the buzzer sound, it means that there is continuity on the line. So now since we don't have any loads in here, there's a gap on the circuit, so we should not hear any buzzing sound when I put my test parts in here. Just like that. Let me turn on the switch. So it means that our circuit is good. Okay. Okay, now let's put in the loads. See if our circuit works. So for parallel circuit, it means that all of your loads gets its own line 1 and line 2. So they are not dependent on each other. Okay. Okay, there you go. Now, let's check. If I remove the bulb here, as you can see, your bulb still lit. The remaining two bulbs is still lit. Okay. Meaning, that's what I meant a while ago, that each bulb gets its own line 1 and line 2. Okay. So if I remove A, same thing happens. The remaining bulb is still lit. Because on a parallel circuit, they are not dependent on one bulb to complete the circuit. Each of them has its own line 1 and line 2. Okay, that's how it's done. Alright, now that we're done wiring, let's find out how much you remember. Let's see if you can answer all 5 questions correctly. You are given 15 seconds to answer the question. Now, I know that you're ready, so let's get it on. Now for our first question. What is the path for transmitting electric current? It includes devices that gives energy to charged particles, constituting the current, such as battery, devices that use current, such as lamps, and connecting wires or transmission lines. Time's up. If your answer is electric current, you are correct. That's 1 point. Okay, for our second question, it is where the electric current starts to flow. What is it? Timer starts now. If you answered source, you are correct. Another point for you. Okay, for a third question. What do you call electrical wires needed in order that electricity from the source can be transmitted? Timer starts now. Now, if you answered path, you are correct. You now have 3 points. Now for our fourth question. What do you call the type of the circuit which bulbs are wired right after the other? Timer starts now. Now if you answered series circuit, you are correct. Now you have 4 points. Now for our last question. What type of circuit whereby two or more bulbs are wired with each bulb having their own circuit? Now if you answered parallel circuit, you are correct. So how many points do you have? Okay, if you got 5 points, congratulations, it means that you have learned a lot. If not, that's alright, you can simply play this video all over again. Okay class, we're done with all of our activities for today, and congratulations if you got 5 points on our assessment. I do hope you had a great time, and I'd like to see you again on our next video lesson. Goodbye.